Today we're going to be talking about drawing circuits. This is a little bit of an art form where we have to consider what are we drawing and that it actually makes sense, but there are some rigid rules. What is a circuit? This is going to be a general idea. It's a loop for current, or series of loops, or whatever. It's some place that current can wrap around, which means we need several things. We need to have a way to make the current. Now, one of the things about circuits rather, is we need to have standardized symbols. Every circuit diagram in the world has the same symbols in it. Like for a battery. The symbol for a battery just looks like that. Now, this has meaning, and there's reasons behind this. Like you have a wire coming in, you have a wire for current going out, you have this small one is the negative side of the battery, the big one is the positive side of the battery. Go get a AA battery, look at it. One side's labeled positive, one side's labeled negative. That's why. Current comes in one side and goes out the other. Why this shape? It actually is an interesting story. It comes down to this guy, Alessandro Volta. I think he only had one L. Yes, the guy they named volts after. He made something called the voltaic pile, which was alternating plates of different kinds of metal soaked in an acid. And what was weird about this was it had a positive and a negative side to it. That was one of the first batteries. So we draw our battery to look like that. Now, sometimes you'll see a battery that looks like small, big, or three of them, or four of them. Each one is called a cell. It's another group of positives and negatives stacked together. Your AA battery is a single cell. Your calculator, get a calculator here, has 4 batteries in it. Each one its own cell, but they're all in a line, so we would draw that like that, with 4 cells of the battery. All right. The next thing you need to have in your circuit is a resistor. This is the thing that, well, the current goes through and is used up by a light bulb, a printer, a computer, a space heater. These are all resistors. The symbol for a resistor, something like that. No, the number of zigzags doesn't matter. All right. Couple other things we need to know about. A switch. You have light switches all over your house. A switch looks like that. So you have current going in, current coming out, and this thing can go up or down. Just like the resistor, current in, current out. We don't need to draw the arrows to show it, but that's what's happening here. We're also going to need to, we might have a specific picture for a light bulb. You will see, it looks like this for a light bulb. Current in, current out, and you have the filament inside the light bulb. Some others you might have. Well, one of the big things that need to be true is we need a way to measure stuff. So far, the only 2 things we talked about we need to measure are voltage and current. We measure voltage with what's called a voltmeter, and a current with, nope, not a current meter, an ammeter. Basically, it's just amp meter shoved together into one word. Important to realize, a voltmeter measures a voltage difference or change because we're looking at energy. We're looking at how the energy changes. Ammeter measures current through. We talk about across. And through. Symbol for a voltmeter is just a V with a circle around it. I know, how clever. Symbol for a current meter, an A with a circle around it. I know, how clever. The ammeter does have current going through it when we have it in a system. The voltmeter does not. That's an important difference. Voltmeter measures current voltage across. It has a start and an end. It looks at how does the voltage change between those 2 points. Consider a simple circuit with a battery and a resistor. All right. Where would you put the voltmeter and the ammeter in order to measure the voltage across the resistor? How does the voltage change as current goes through it? And the current through the resistor. Well, when we measure voltage across, we're measuring at the start and at the end of the resistor. We want to know how the voltage has changed because we want to talk about the change in energy per charge. But for current, we want to measure in line with it. We want to have it go from one and then through the other because the current just keeps going. All right, I'm going to put a problem up, give that a shot, and we'll go from there.